Okay, we are live. Uh, Today we have a new guest friend. Hi, Christopher. Uh,
Hey,
so, yeah, I don't know where you are located, but we meet at this time weekly. And yeah, welcome to the group. Maybe we can
cool.
give a short introduction. So
Sure.
I can
Uh,
start. Uh, yeah, I'm Anuraj and I'm basically a roboticist by education, but these days I do software consulting and I'm based in Finland and yeah, and build hobby robots and rovers for fun. Maybe Eric can go next.
Sure. Hello, Christopher. Nice to meet you. Eric, originally from France, but I've been living for my life in Japan. And my specialty is called AI, but I'm not sure what it means today. Okay. Um, Otherwise, yes, pretty much involved in robotics from the AI perspective. And yeah, pretty much like Anuraj, like hobbyist mode in this meeting. Mayor?
Yeah. Hi, my name's Meir Fenster. I'm from Israel and I'm a patent attorney by trade. I specialize in medical devices. And yeah, I'm here for the hobby value.
Hey, Christopher. I'm Venkat.
Venkat, you want to introduce yourself?
Yeah. So, hey, Christopher. I'm Venkat. I am based in Seattle, and I'm a writer and management consultant, also in hobbyist mode. Long ago, I used to be an aerospace engineer. Now it's all engineering is hobby level. So, yeah, tell us about yourself.
cool. I'm Christopher Bodie. I live in Pittsburgh, Pennsylvania. Software engineer for the last 11, 12 years. Not by training. Actually, I went to Carnegie Mellon, but I studied creative writing. So sort of like a funny path to get here. And then, yeah, interested in robotics instead of sort of just fiddling around in my basement by myself. I thought I'd see what other people are doing.
It might be some weird time there, right, in Pittsburgh?
Yeah, it's
Yeah.
12:30.
Okay. Yeah,
It's
and okay,
challenging.
okay. Well, let's start, I think. So today we are going to discuss some discovery protocols for the robots on the internet on a planetary scale. So we have been discussing that for a few months now. Eric has some presentation. Maybe you can share the screen, Eric.
Yeah. Yeah. So, here we go. Okay, so sorry for the cheesy name, but I'm not super creative. Not a good time. And since Christopher is here, it's great because I'd like to start first to try to remember what we want because the thing Anurag just said that we've been discussing that for a few months, but there is so much technology involved, different protocols, different standards, and so on, that it's easy to lose sight of what we uh, what we try to achieve here. Okay, and so the problem is, so before I get to this scenario or unified scenario, I call it is that um, I don't know how many times Venkat was referring to this scenario where you come to your home, okay, where you have your laptop and you start working for your robotics project, and the robot is next to you, and just to connect to that robot, you have so many steps basically, right? Okay, so you have your we use a robot called the tumbler. Okay, Tumblr is just here. We just want to continue, but we have to connect. We have to put some cable and this and that, while everything's on the wireless basically. Okay? So there is this typical scenario. Okay, so it's entirely local, and we would like that to be completely automated. And there is the broader scenario where that involves another topic we talked about called the cryptobotics. especially around the YaRG, where basically, for example, YaRG has his Tumblr next to him, and I am in my home, and I like to connect to his Tumblr to spy in his apartment, basically. Okay. So silly example, but
Tumblr,
we have.
yeah.
Just a moment. Yeah, so Mayor is showing the Tumblr
Ah,
robot. Where
cool.
did it go?
Okay.
Can pick mine too.
Yeah.
No, I can't.
So this is the platform we have. So it's like it's a 75 dollars small robot, self-balancing robot, and it didn't come with a like wireless microcontroller, so it just had Bluetooth, and then it also comes with a phone app that you can like control it. So since we wanted to do some crypto stuff with it, like what we designed a custom PCB with a ESP32 on it. So right now, basically, we can control it via Wi-Fi. So basically, like it also hosts a simple web server with API endpoints, and then you can call those endpoints as a GET request from any server, and the robot would move. So, and around 2 years ago, what we were able to do was basically, I don't know if you know Farcaster. So, Farcaster is a crypto social network, and it has some crypto like a payment gateway like affordances. So, what we did was we were able to payment gate the control of the robot, and then you could pay in crypto and take control of the robot. And these days, there is a new protocol called X402. Basically, it was proposed by Coinbase, but there are other large tech companies also involved these days. So, right now, we have a basic kind of a demo server which you could log into with your wallet, and then you can like select the rover you want anywhere in the world, those who have registered, and then you get the control of the robot. So you right now the payment is in like USDC, and then like the idea is like you can also collect earnings from renting your robot. So if you see the repos on the Yak Robotics Garage, there's like a React Tumblr Fast API server. It's like already online on yakrover.com. So if you go to yakrover.com, you will see the login page, but it's like restricted to certain wallets we have. So it's not fully functional, but you get the idea, like what we are trying to do.
Very cool.
Uh, yes, Eric.
Yeah, and all that led us to see that there is a typical problem with discovering dynamically, automatically, okay, other rovers, okay, and of course, if possible, it should be secure and so on. Okay? And so this leads to this discussion and to this unified scenario. Unified in the sense that ideally we'd like something that works, that feels working the same locally when we connect to the rover that is on the same table, or to some other rover remotely, perhaps with payment and so on. Okay? So the idea is to go somewhere, for example, our office or home or whatever. Okay, we open the laptop, we go, for example, to a predefined URL locally, okay, and that URL is backed by a protocol, okay, so the one I'll be discussing just after, that gives access to a robot on the local network and to a search tool for robots that are globally available. Okay, so that's the basic idea. And but to try to have everything unified for convenience. Okay, so there are a bunch of problems. For sake of discussion, I will just skim on them. Okay. Um, but the thing that after several readings, after several discussions, I think it's very important to assume that everything is untrusted, basically. Okay. So then what can we do when everything is untrusted? Okay. And so this is where we have a link to blockchain technology, basically, and to some protocols that have been proposed recently to deal in such kind of environments. Okay, so I will come to that a bit later. Okay. After there are a bunch of technical issues, like there are discovery protocols on the network. Okay, we'll be talking about multicast DNS and stuff like that. But these find anything that has an IP. Okay, but for us, we are interested in not anything, but something like a robot. So how do we find a robot there? And after there are some questions that maybe out of scope because I don't remember us discussing much about that. It's more about a roaming. Okay, is that here we talk about a local scope and a global scope and so on. But what happens when we move from local to global and so on? Can we be available both on local and global? Such kind of questions that have technical impact. So a bunch of problems like that, but stuff that we can review step by step. Something a bit interesting that we have kind of implicitly discussed, I think, is what do we mean by discovery? Okay? And the thing that we can see different levels, and so that's interesting to structure any technical solution we come up with. Okay? And so at the base of discovery is I try to call that with a single name, to name it with a single term. Okay, so it's existence. Okay, so basically existence is for us is something with an IP. Okay, and based on that, the notion of identity. Yes, it has an IP, but is it something that we can name? And so, in particular, something we want to use. Okay? So, for example, does it have a domain name? For example, or now in crypto and agent and so on, something called an agent ID. And so, once we can name it, there is an affordance. Can we do something with it? So, it's typically a client-server relationship here. Okay? And on top of that, there is the term I chose agency, okay, but it's a bit overloaded these days. But agency is more like client server in the sense that we can really actively enter in a collaboration with that entity. Okay? And so there are all these steps to discover, I think, for robots where agency could be about the robot here, okay, the top level. I skim, but please interrupt me. Here, I try to put on the slide the different technologies we've discussed, and that retrospectively look like really relevant here. Okay, so we talked about this one, the ECR 804. Okay, so also named trustless agents. And so this one, sorry, may I ask a question?
No, I was
No, sorry.
reading out
Okay.
loud.
Okay. So this one is not about discovery, okay? But I have some doubts because of after reading the standard. Anyway, it's about a dynamic reputation mechanism backed by blockchain technology, okay? It's super interesting, by the way, okay? This one, so ECR 721 is mostly called as the NFT, okay? So NFT is it can be quite it's a concept that can be difficult to understand or to wrap our head around. Okay, but here, what is very interesting is that they cast this word of NFT as an ID. Okay, so it's about this layer, in fact. Okay, so in the ECR 804 protocol, an agent ID is an NFT. So it's quite interesting how these things go together. And I talked about the payment protocol just a moment ago, the X402. Okay, so it's into brackets because I try to have this slice exclusively about discovery. Okay, so payment can be on top after that. We'll talk about the Zeno network protocol. Okay, the 8-way agent-to-agent protocol. So Zeno is really about networking. 8-way is about describing the capabilities of our agents, or which are robots. Multicast DNS, okay, which is pretty standard and well known for people on Apple. It was called Bonjour, okay, and on Linux it's Avahi. Okay? We talked about MQTT, which I decided to put really out of scope. I'll explain why. Okay, And Anurag found this chaos chain, okay, which is very interesting because there is a lot of overlapping. Okay? It's using the very similar technologies, but I will explain how what we are trying to do here is different. Anurag also shared a Claude thread where he was exploring Zeno and MQTT. Okay, and so I read all that and I studied based on that. It's very interesting, but I can't find the link anymore. Okay? So Anurag, if you have the link
Yeah,
again,
I can
it was,
paste it in Discord. Yeah.
yeah. And so by doing further studies, I think that that thread on Claude is really helpful. Okay, but they it's missing a few things. Okay, so it's around this kind of thinking, but we'll see later. So here a few words. So project name for now is called the Disco. Okay, whatever we choose later, but basically putting together the different technologies we've been discussed recently. I've tried to put together. Okay, how can it work? Okay, so first it's a client server protocol, but it's also a peer-to-peer. Okay, because when I open my laptop and I want to connect to my Tumblr next to me or to the one next to Anurag, it's client server. It's over a peer-to-peer network because eventually we also would like the perhaps okay the robot to communicate with each other. Okay, that's something very interesting. If you have two tumblers side by side, if they can discover them, if they can discover each other automatically, that's we can see a lot of benefits here. So there are two parts: server protocol and client protocol. Okay, so big words and protocol. Here is just an outline. I partly implemented it to try, but anyway. Here, the idea is that everything is IP based. Okay, and so that's about discovery of existence. Okay, the bottom layer. Okay? So we need the assumption here is that we have an IP ready hardware. Okay, so what is interesting, like it doesn't have to be. If we have another protocol than IP, it should work as well. Okay, but on top of that. The idea is that a server, okay, so a server here is typically a robot, okay? So it exposes a TCP endpoint with what is called an agent card. So the agent card comes from the A2A protocol, so agent to agent communication. Okay? An agent card is an agent card, yes, is a JSON document where we put typical data, okay, especially who the agent is and what the agent can do. Okay? So here it's just claims. So an agent, a robot claims that it can fly. Okay, maybe it cannot. So this is just a part of discovery. This is where we will have after this part about the reputation. Okay. Anyway, we have an IP and we expose a JSON document on a predefined port. Okay. So this is to link to this to have everything of a convention, right? A bit like DNS and HTTPS and so on. All of them are conventions, basically. Right? And so this is all. This is the minimum. Okay, I will explain after why. Okay. On top of that, we can use Zeno. Okay. So we reviewed it a bit last week. So sorry, Christopher, because I will skim right now, but we can get back to it. Okay. But the Zeno is a network protocol that can work in PM mode, where on a local network, automatically we can find all peers. And so if this piece have this convention, okay, we have identity not only at these basic levels, but also at the higher levels, okay, because we know who they are and what they provide. Up to here, everything is valid on a local network. But after, if you want to move globally, this is where we use extra pieces. So on the Zeno side, we use Zeno routers. Okay? So whatever the technology is, but it allows us to globally address other robots. Okay? And this is where it really matters to introduce the trustless entity protocol. so that we can filter out, if we want, okay, what we find on the global network can be filtered out more easily. Okay, and so that can help for in many cases. So quickly on the client side, so it's typically my laptop, okay, or a robot that wants to connect to another. So there are two modes here: the what I call the local mode and global mode, okay, and it's pretty much similar to the server side, okay, where but in local mode there are a lot of things we can do. Okay, we can do a plain network scanning. Okay? We are on a network segment. We can scan. Typically we are on a segment where there are 255 addresses, something like that. Okay, and so it's very quick to scan that. Okay? And so with the convention that on all the IPs on the segment, so 255 IPs, we look for this port, the port 2026, for example, and this file we can scan automatically on the network. And so when I open my computer, we can have a completely automated discovery of a compliant robot. Okay? And so I can start working immediately. Kind of. More complicated and optional, okay, is that if MDNS is available, we can also use an MDNS. Even more, to quote, complicated and optional is the Zeno, again in PM mode. Okay, so this works on SBCs and MCUs. Okay, but on MCUs there are restricted capabilities, so I don't know the difference exactly. So that's why I think this should be optional because it requires Zeno anyway. Okay? In this case, we can use the agent class directly. Okay, because we are on a pseudo trusted network, which is not always the case if we are in an airport or whatever. Okay? Where we access here the capabilities to know what the agent can do. Okay. In global mode, so we don't have the network scanning, we don't have MDNS. Okay? So this is where Zeno really becomes a key piece here. Okay? And what is interesting is that Zeno, okay, so it's a network protocol, but it's really data driven. Okay, so basically you can make a query that is automatically distributed over the network, and with the query with a specific key, okay, so something like a name like that, okay, we can automatically find globally whatever robot can answer specific capabilities, specific skills, okay, and so this really relies on the query system in the Zeno protocol. And so the main reason to start to go directly into that is scalability, because globally we have an arbitrary number of robots, right? But out of these results, this is also where the reputation mechanism comes into play, because Zeno provides a discovery, okay? And inside the discovery, we have we do need reputation in a really untrusted environments. Okay? So this is where it plugs in. I will skip on the last comment. Okay, so the last slide, because very long monologue, right? You try to compare with something called chaos chain. Okay, so chaos chain, I put the link a little bit earlier here. Here, okay, you have the link here. Chaos chain. They call themselves a platform for agent accountability. Okay, and the thing is that a lot of the technology is really the same. Okay, the ECR 804, A2A, and so on. Okay. The big difference, there are two big differences. One is that there is nothing about networking. Okay? So it's really not about discovery. So that's why it doesn't address, it's very interesting, it doesn't address what we're going to do here. Okay? But second, there's something very interesting, is distributed knowledge graph, a DKG that they provide. Why? Because this allows to create a collaboration between agents, structured collaboration. Okay? While the ECR 804 reputation mechanism is per agent, basically, or per robot, if you will. It's not about how they can work together and do stuff like that. So, because it doesn't do networking, it's not what we're trying to do. One thing, but in the future, when we talk about multi-robot collaboration and so on, this DKG idea looks like a very good idea. So a few pending problems for the technical discussion to geek a little bit later, but that's about it. Just to conclude, what I explained here, I'm trying to code it as a prototype, so as a Python library for now, to see how it works. And last week we mentioned about making perhaps a small simulator, okay, so that we have everything running on a single computer to see how the thing evolves. Okay, so working on that. I'll share a repository where for now I have a prototype discovery over sorry, network scanning, direct scanning, okay, MDNS and Zeno. Okay, I haven't done anything on the trustless agent part yet. Stop here. Any question? So it's a bit dense with all
8004
the
has
technology.
some discovery, right?
But this is something that I don't quite get. I think it's one of my questions here. Okay, because the thing is that it's I don't think so. I don't think they have discovery at all. Okay. What is strange is that in the protocol, if you register your agent, maybe it's easier if I share a screen with the. I put it here everywhere, but I'm sorry, it's ERC. Huh?
Yeah, actually, right now it's already on the main net. It's now right now an EIP instead of ERC, I think. It's not a draft
Okay,
anymore. It's on the Ethereum mainnet already. I think last week they have it on the mainnet.
okay. I will look into that. But you see, when you register, so it's a protocol where at some point you have to register what you can do. So can you see my screen with the JSON here?
Yeah.
Yeah.
Okay. So basically you have a bunch of data to provide, and you have especially the services. Okay. So it complies with there is a web server, it complies with A2A, it complies with the MCP we talked about as well, and some others. Okay. But there is this, okay, supported trust. Okay. So is that your agent, your robot, your compute, okay, does it support these trust models? Reputation, crypto economic T attestation, okay, so different models of trust, right? Okay. And so, but this is optional, this field. And what they say somewhere, uh, yes, if supported trust is optional, if absent or empty, this ERC is used only for discovery, not trust. Okay. So for me, this is super ambiguous because where do we have discovery here? This is a model of trust and distributed reputation, okay? But there is no discovery mechanism, at least not the way we talk about it. Okay? I didn't get that part at this point.
Is there a public registry at some smart contract address or something where you can just go search, for example, all the robots in Ulu in Finland, and then maybe from the list you can discover Anuraj's robot and then click on it and get its IP? Is there like a
So you
like
can go to 8004 scan.io or .com, and basically it keeps scanning the blockchain for registered agents. So right now it's like software agents, but you could easily extend that to registered
Yeah,
robots. So,
okay? So that seems to solve discovery for me. So I'm not sure I understand what you're saying, Eric. What do you mean it doesn't do discovery?
but the thing that the whole document, use the word discovery, but there is no explanation of the mechanism. Okay? So apparently, what you're saying now is that there is some website that we can connect to scan the blockchain or something like that.
Let me perhaps explain. I can go on Google and get a list of all the psychologists. That doesn't really solve the problem that I need a specific psychologist who deals with short-term treatment for fear of flying, let's say. there's a process that I go through when I look for a psychologist, and just seeing the name in yellow pages on Google isn't all of it. So there's a mechanical availability of some very little data, but I don't think it's enough for me to do what I call discovery in my life. And I'm wondering what discovery looks like for robots.
But at least like you start with a location based search, right? For example, if I want to search for a physiotherapist, right, so I would
Yeah,
search like physiotherapist in Olu, right? And
yeah.
then I would go and see like what are they specialization in, or like what is their reputation or whatever. So at least you start with the location based search, right,
I'm
initially.
agreeing that it's part of the answer, but it's not the complete answer.
How much of it is just being able to search on rich semantics of fields, right? Location, specialties, affordances, permission, security. There's like, I think 90% is just knowing it's there on the blockchain or something else you can scan. The other is just being able to search on a number of filter criteria. So is this just 100% a filter problem, or is there something that is more than having like a full directory resource plus filtering and query technology? Is there more to it than that?
It's also like rap, at least for humans, it's rapport based, right? Like if you are at least searching for some physiotherapist, like how you go and use something, and then if you feel right, then you go again. I
Yeah.
don't know, it's also like interaction, a little bit of interaction based at
Okay,
the
so this
end.
is like a dating site or an employment site, right? Uh,
But
so yeah, there would be a couple of
dating
trial
is a
dates
great
or
example.
yeah.
Venkatesh, dating is a great example, and so is employment. Most dates fail. Employment, I mean, at least the numbers I see on the internet, you send in 1,000 resumes and nobody gets back to you. Okay. You can't call that discovery. There's some missing steps.
But I don't think like dating has been solved for online, at least. Like it's like
So
numbers game everybody is playing.
so I
The-
would say the this is actually a
exactly.
missing block in the block diagram. So Eric, in your pyramid, I think I put this in the comments as well in the chat. But I think a missing part is basically verifiability of claims, right? So the reason you have mechanisms like dates or 2-week trial period in a new job or whatever is so that the claims that have been made in your discovery declarations can actually be tested. And in this case, if you want to expand discovery to include that point, you would do something like the example I posted in the chat was, Eric, you mentioned like, the robot may say, I can fly. So the
Yep.
correct challenge to that is, all right, prove you can fly. The correct response to that is, all right, here's a photograph taken at timestamp T from this altitude above the house at the location I'm in. And maybe there's some element in the photo that cannot be faked with AI or something. So the equivalent of like, what you used to do with kidnapped victims holding up a newspaper or something, like, the equivalent of that for everything. So this, I think, is like a general problem in blockchains and also not blockchains. How do you make verifiable claims, and how do you create this whole what is that PBS type mechanism, right? Prover,
Like,
builder, kind of like challenge protocol. And I think there's another example worth putting on the radar here is IFF, the identification friend or foe protocol used by military aircraft to, identify each other's radar signatures. So if there's a plane coming and it claims to be from the same air force as yours, they go through a protocol that basically handshakes and proves it, right? So I don't know if you want to put that as a separate layer. If you want to include it in discovery, that would be verifiability. So I would say, yeah,
so once again, I have a comment because I wonder whether that's actually applicable here, in the sense that a, I think that's why we are very interested in this ERC protocol, because there are the validators, okay, validators which are, for example, if I register, okay, identity registry is where we register our agent or robot, okay? And if I claim that I can fly, nothing prevents me to do so, okay? However, everything I will do on the network will get validated, okay? So over time, if I claim I can fly, but each time someone asks me to do something flying, I fail, okay? The validation will make in the end, my reputation go down, okay? So it's eventually we go to we get we get verified basically over time. Okay, and I think that that's very flexible because to verify I can fly. The example you gave, Venkatesh, is that is very specific to flying. Okay, to take a picture in this scenario with GPS information and so on. Okay, and so if we want to have an arbitrary mechanism, okay, that can verify anything, it becomes very hard, right? Because we need to have to identify how do we verify this and that each time. Okay? While here we just have a claim. We just have claims backed by reputation, basically, which is validated by third parties.
So this is basically you're socializing the verification into kind of like a social attestation process. So instead of like
Yeah.
doing a challenge and response protocol one-to-one, you kind of use the proxy metric of 100 people in the past have tried to challenge this guy, and 80% of the time he proves that he can, do a flying job, and that's
Yeah.
all you need, right? So you're relying on social proof essentially to finesse the hard problem.
Yes, and so there are social proofs do have a lot of weaknesses, but in this protocol, which I think is not completely bulletproof. Huh? You see, there are different techniques like so. What is the terminology? Okay, so if validators that don't do their job well, basically they get slashed. Okay, so they get penalties as well. So it's a social, but also not just basically the census-like accumulation. Validators must be registered as well and have their own reputation.
I
So
don't know
one
why does this encourage robots? Sorry.
Go ahead.
Yeah, I was gonna ask, why does this encourage robots to sign on? Okay, I keep hearing why it's bad for them. The
What?
reputation can suffer and so on. Yeah, they get work, okay, but if it's so painful, somebody will have another solution, and they
Mhm.
won't, joining our registry.
So the idea to register here is to become available. Okay, but being available is like going on job market, right?
Yeah.
We are available. It doesn't mean we will take a job. It doesn't mean we will get a job, right? Okay. So first, here is more like a layer at a layer where this is where we're trying to focus on discovery. Okay, the reputation involved. Okay, but the core problem is really about discovery, right?
Well,
So the motivation is just to be visible, right?
I'll say it differently. It's like being a seller on Amazon or AliExpress. You're continuously being squeezed, and there are all of these different tools that can be used against you, including reputation and price comparisons and so on. And I'm asking, why would a robot, or the owner of the robot, depending how AI it is, why would they agree to be on a register where the outcome is that the reputation suffers? They're asked to do all sorts of silly tricks in order to prove them. They keep getting rejected.
But LinkedIn works for people, right?
It doesn't work for people. It doesn't work for people. Okay.
So, yeah, I think the basic motive should be separated from the efficacy of the mechanism, right? So the basic motivation for all the networks we've talked about with humans it's either something like money or finding a partner or something like that, right? So there's a motive, and then there's a question of does it work well. In this case, we've already experimented with it being like, the motive is making money. The robots are online. If they can be teleoperated, they can make money for as long as they can be online, so they become earning bots. So that's the motive. Now the question of how well it works, I think the two mechanisms have like complementary strengths and weaknesses. So direct proof has basically technical difficulties. So if you want like a direct one-to-one challenge proof kind of protocol for proving you can fly or have a manipulator or whatever it is, there's a technical problem to be solved. On the other hand, if you rely on like social signals, somebody has to pay the discovery cost when an actor is new. So a new robot joins the network, somebody has to like try 10 times before we figure out whether it's reliable or not. That's one problem. Another is what I think all the DeFi people have discovered, even with like something as simple as tokens, right? There's a liquidity problem. If there's only 5 robots in the world that have some weird affordance and only 5 people in the world who are trying to use it in different parts, the market is simply not going to clear. It's not going to have like enough liquidity to do the social reputation job. So I think one takeaway from this discussion for me is we probably need a question mark box for doing both. Like if there's a reputation signal with enough liquidity, we can use it and like try to trust it based on the statistics of it. But if there's no reputation signal, it shouldn't be that no transaction can happen. At that point, we can have like some sort of challenge response protocols, right? Like you claim you're the only shape shifting magnetic memory alloy robot on the planet and you can do certain things. Prove it to me. And then it sends back a demo video, right? So it doesn't have to be super complex, but I feel like we should add that at least as a placeholder, right? Like you discovered the robot's address, you filtered it by criteria and narrow it down to 5 shortlisted candidates. 3 of them look like they may be able to do what you want, but it's not explicitly modeled in the ontology. So you send them each a task request and say, hey, I need this particular kind of photograph taken with an IR filter or whatever, right? You specify a task which is not exactly mapped to an affordance. And then all 3 of them, just like submitting a resume to a poorly defined job description, the robot send in a resume. In this case, it would be some sort of proof. And then you do some analysis and say, all right, this seems worth the risk. And I think the interesting thing with AI is a lot of this can actually be made extremely soft instead of hard. It can happen in natural language the way it does with humans, right? Like we solve this kind of problem routinely all over the place as humans. You go to a new town, you ask somebody directions to some place, and with some hand gestures and like clumsy language, maybe the guy gives you directions and it turns out to be right or wrong. It happens a few times. You learn how trustworthy the people of that foreign city are, right? So we solve this problem in very soft ways in human reality. So I have a feeling we can solve it equally softly with robots now, right?
Um, I'd like to suggest something really soft. Instead of me proving that I can fly, I will give you a simulation of my robot, and you can prove that it can fly. In other words, maybe the way to make discovery is kind of like a dating app, and instead of having pictures, we have the equivalent of an avatar. So instead of the robot having to prove something that it can do, it lets the buyer evaluate if the robot can do it. Because imagine that I can fly, but each time I fly, it costs me $2 in fuel. Well, 20 people a day asking me, that's already $40 a day without any work. But since robots are simulatable, we can move from the real world to the software world, and then you can take my robot model, and the reason you can trust it is because I do have some sort of reputational score, and you can see what happens if in the simulation if you throw me off the roof and so on. So it would be somewhat different from just data on a list.
It's a digital twin, right?
It's a digital twin, and you could also have a special service which tries out the digital twins. In other words, if I'm a little robot and I'm looking for somebody who can fly me from one lawn to another to mow the lawn, I don't know how to evaluate that, but there is a service which I can give it the identity of a robot and exactly what I needed to do. It will run the simulation and say, yeah, he can do it, he can't do it.
I like that, and I think you can actually combine the two strategies because you don't need. So you can sometimes generate proofs, but you don't have to generate it for every request, right? You can
Mhm.
generate a proof like once a week saying, yes, I can still fly. The drone is not broken, right? So you do that as an attestation. So you have like a week old. It's like having the most recently
Yeah.
updated resume, and then you also provide basically a testable simulation model that can support proving some claims. But I also wanted to throw another protocol on the list, the Ethereum attestation service. So we used this last year to generate certificates for the protocol school we ran. It feels like if you want to make very specific claims and you want to attach proof to those claims and have it attested somehow, this may be a useful extension of what 8004 does. So this is basically, yeah, you claim something, it's a bunch of metadata fields, you publish it as a ticket on the blockchain, and then it exists as basically uh, a certification. It's like, what do you call those things? A notary service. So, and I
I
think you
think
can
Yeah.
attach, proof in the form of like IPFS files, videos, stuff like that. I don't know. So there's like a bunch of I don't know if this is redundant and 8004 already covers something like this, but if not, this might be a good extension for attestation
Yeah.
things.
It is. That's nice.
isn't the fast camera, what was it called? The ZK verified camera using this attestation in something. At least July was mentioning this.
Yeah, though his camera does a much deeper attestation, right? It's at a hardware level. The ARPA assigns the image immediately after it comes off the CCD. So it attests through a physical proof from the device, and then I don't know how it publishes it. This is a publication mechanism for attestation. It's not a generation mechanism. So you'd have to like include other things like, private key signed images with like a hardware key. I don't know what you would do. But yeah, July's camera does something at the hardware level, right?
Yes, I think even recently, until recently, the camera basically to get the images out of the camera, it was just maybe by an SD card or something. I think it's getting connected just now in the next iteration because everything is really, really on device, and maybe it's a system of watermarking some the proof metadata inside the image, something like that.
Yeah, it's called a rock camera. I just shared the link again if you want to quickly refresh our minds on what the camera does.
It verifies that the picture you took, which might have been set up, was actually the pictures that you took.
Yeah.
Mhm.
So do you have to be cautious about like what level of trust you have? I think it's something like there exists a hardware camera with a particular signature somewhere in the world, and this proves that this picture came out of that camera and has not been modified since then. I think it's a claim in that of that type.
Right.
Hmm. Yeah, but you can't make that claim. Maybe the robot lost a leg.
And if you upload one such picture per day at 9 a.m., it shows that at least in the last 24 hours you are alive for 1 minute and your camera is not yet broken.
Yeah, but that's a camera. So we could be using blockchain in robotics in order to prove that you're still the same robot you were yesterday. When I mean same robot, I don't mean your identity, I mean your capabilities. Remember, we talked about the robot wakes up, it stretches its arms carefully, of course, and does stuff. So we could use some sort of crypto mechanism so that the robot, every time it wakes up or once a day, can provide proof that it's still the robot it was when you when it published that it can fly.
So
Let's say I flew and my propeller broke because I flew. I'm going to keep that secret.
I had a thought about this is like a probably absurd way to try and solve that problem, but it's like interesting as a thought experiment. You could take the sort of like hierarchical physical structure of the robot and map it to a Merkle tree, and then the Merkle tree will basically become invalid if a piece of the robot breaks, right? So you guys know how Merkle trees work, right? You make like a tree-like structure with basically each level of the tree is a SHA hash of like the nodes below it. So the top level thing will not be stable until everything below it is stable. So in this case, to use your example, if the propeller breaks, the Merkle tree maybe in some sense cannot be constructed because the private key of that propeller happens to just be, I don't know, physically inscribed on that, and therefore it cannot sign its proof that it still exists or something. I don't know. So there might be a way to like, I don't know, do a Merkle DAG based proof that you're still the same robot. And if not, you can at least prove to what extent you've changed. The ship of Theseus metaphor of you take off the ship's mast and replace it with a new mast. Is it the same ship, right? You can turn that into a variable. You can say that, all right, it broke but was repaired yesterday, and the overall vehicle has the same private key, but it has a new camera, something like that. So you can make reasonable claims of that sort if you use like Theseus Merkle trees. Maybe we should invent this and prototype with Theseus Merkle trees.
So this idea of Merkle tree, I think, would be very interesting with a statistical system of the different pieces. What I mean by that is in the robot, in the bomb, in the tree describing the bomb of the robot, okay? We have some, for example, a sensor or a motor or whatever, okay? And these, they have a statistical signature, right? I mean, they have a static signature, okay? But when we use them, they have also peculiarities that make them having a usually kind of unique signature. If the hash is applied to some statistics on these different pieces, we can get something pretty unique, huh? If I'm making sense.
Yeah, I think you can, but I think there'll be it won't have the properties of a cryptographic hash, right? So you're talking about fingerprint like statistical signatures, which with 99.99% probability can be close to only one other fingerprint in the world, right? So that's one kind of match. But then because of the way cryptographic hashes work, that would be different. Like even the tiniest change would make it randomly very far away in hash space. So that wouldn't quite work. So there's a research problem to be solved here. Like how do you do it? Yeah.
Oh, it's certainly an open problem, huh? But that's why I'm talking about statistical properties. Okay, that must be computed enough to be stable. Okay, so I don't know the mean and the standardization typically. Okay?
No, I mean, like, these are two different things we are, right? One is actually the identity, and the other is basically kind of the affordances the robot has. So for the affordance, the statistical matching could be enough to know if the robot is doing some or capable of doing something or not. But the identity could be separate thing, right? So it could be a more cryptographic identity that doesn't change or doesn't need to change. But the
And so
affordances can keep changing, right? So it could be something statistical.
But the two problems are coupled, right? So today, with my private key, I claim that I have a manipulator motor capable of lifting 5 kgs. Tomorrow, a contract comes my way saying, can you lift this 5 kg object for me? But in the meantime, my motor broke and I replaced it with a cheap motor that can only lift 2 kg. But I take your money anyway based on my identity and claim and run away with it, right? So I think you kind of have to do both levels. So I think there's a map and territory distinction here, and you have to prove both that the map is the map you claim it is, and the territory is the same. But I think this is actually solvable in some way. Yeah, I think the statistical signature stuff could work. And the approach I'm thinking of is actually the one used in Ethereum for data availability sampling. Have you guys seen this. So it's like,
No.
the validators are supposed to keep certain blocks of data around, and others can challenge them to say, do you have this data? And the way they do that is sample an arbitrary row and column, something like that. I've forgotten the exact details. Anuraj probably remembers it better. But you can do something similar to data availability sampling for the statistical distribution of, say, it's how steadily it moves objects, right? Because these may actually be parameters you care about. You want a high precision robot that can move with like 6 sigma tolerance from point A to point B, and therefore you want to sample its I don't know, movement jitter or something like that. So there's something here. I think it's promising.
Yeah, and I think this combined with the reputation in the 8004, you could basically kind of have a trusted or like trusted discovery of robots. It's yeah.
Right. All right. Time-wise, we are almost at the hour. Just one thing that here on what we talked about today for discovery. So it's definitely a, let's say, a complex problem. Okay, a complicated problem with several aspects. But it seems totally interesting to implement and use with our tumblers the low-level discovery, if I can call them this way. Okay. So, for example, using the scanning on the local network, MDNS, and maybe also the Zeno auto-discovery capability in peer-to-peer mode. I'm almost done implementing that, actually. Okay. For the moment, I implement it in Python, so it won't be usable directly. But if you get that to work, it would be at least be convenient, right? If we can just open the laptop and be connected to the different robots that run it.
So have you tried porting XenoPico to ESP32? I
So
think they
it's
have.
running.
There is a sample somewhere I had seen.
Okay, yeah. It runs on what, the Pico by the one available? It's
It
on the
runs
run.
on the standard. It's on the ESP32. So the standard example they have, it runs on ESP32. The XenoPico.
Okay.
And since we are on the Tumblr thing, so I made some progress on the self-balancing part with Claude. Not fully my contribution. A lot of Claude lifting the weights, but yeah. So I ported almost everything that was there in the AVR code, the Kalman filter, and the state machine. The AVR code was running. I haven't tested it yet, so it might need some tuning. But yeah, it's there sitting on a branch. If somebody wants to play with it, you could just check out this branch and ask Claude to help, and it might help you.
Yeah, thank you. Great.
Yes, we are at the top of the hour. Do we want to discuss something else, or
The article shared by Venkatesh on the humanoid, last something.
no.
Yeah.
It's quite an interesting document, right? The introduction is pretty short, and after for each section there is what to re- what to get from the section. Pretty well structured, interesting. I found.
Yeah, we should have a full session on humanoids maybe next week or so.
Will that next week? Okay.
Yeah, it's a full deep dive topic. I think there's just a huge amount of stuff going on with humanoids.
Yeah.
Okay, so we meet next week for the humanoid topic article. Thank you, guys. Bye.
Thank you.
Thanks, everybody.
Bye.
Bye.
Nice meeting you.